All right, this question is asking about calculating the WACC, and when you calculate WACC, you are going to use this formula. We're going to weight the cost of capital. You have to remember the after-tax feature of debt. And we have preferred stock, and we have common stock, which is what we call equity. Now let's get into calculating the weights. Now to calculate the weights, we need to know what the market values are of everything. And we're told that this company has 10,000 bonds, and each bond's market value is $9.50. And so note that we want to use the market price and not the book value, not the par value. So that's $9.5 million is the market value of the debt. We're told that there are 1,000 shares of preferred stock, which has a market price of $100 each, so that gives us a market value of $0.1 million of the preferred, and the common stock is given to us directly with a market cap of $20 million. So the market capitalization is the market value. If the problem told us information about the book value, then you would just need to know to ignore it and still use the market value, or the problem may have said to number of shares and the share price like it did with the preferred stock, and then we would calculate the total market value in the same way as we did with the preferred in this problem. We add up all of the market values, we get the value of the whole firm, which is $29.6 million. Now let's get into calculating the costs of debt, preferred, and equity. Now the way you calculate the cost of debt, the before-tax cost of debt, is to calculate the yield to maturity. This requires using the financial calculator. So let's look at the information about the bonds. They're 5-year bonds, but it's semi-annual, so there's 10 periods. The price for each bond is $950, so we're going to put negative $950 into the calculator. The payment is the coupon payment, and the coupon rate is 4%. Coupon rates and yields to maturity are APR, so therefore we have to split this in half to get the semi-annual payment, and the par value is the future value. We compute the interest rate for this problem, which is 2.5736, giving us a yield to maturity of 5.1469%, because we have to annualize it. So remember, yield to maturity is an APR as well. Right, now let's talk about the preferred stock. The cost of preferred stock is found by just taking the dividend of a preferred share divided by the price of a preferred share. In this case, it's 6 divided by 100. So we get the cost of a preferred share being 6%. And to get the cost of equity, we're going to use the security market line equation. Some problems have you calculate it using the constant growth dividend discount model, but this problem clearly wants us to use the CAPM security market line because that's the information that's given to us. We have the risk-free rate is 3%, the beta is 1.2, the market risk premium is 8%. Pay careful attention that this tells us that the premium is 8%, so therefore we do not subtract 3% from that 8%. Sorry, the risk premium is 8%, we don't subtract 3% from it. So we have 8 times 1.2 plus 3 is 12.6% is the cost of equity. All right, now we're ready to put all of that into our formula for WACC. So the weights are 9.5 divided by 29.6 is the weight on the debt. The before-tax cost of debt is 5.1469. We have to multiply that by 1 minus the tax rate. We scroll up, we see that the tax rate is 30%. And then the weight on preferred is 0.1 over 29.6 times 6. and the weight on equity is 20 divided by 29.6 times 12.6. All right, you put all that together, and we get 9.69% is the weighted average cost of capital. Let's look at the top to see that that option is there, and there it is. So our answer is C for this question. All right, that question was quite involved. It covered lots of different things that could be covered in other chapters. For example, the security market line equation of CAPM. So that'll be a particularly valuable problem to review. Let's move on to question number 2. This question is a loan problem, specifically Chapter 5 problem, and is a great opportunity to use the timeline. So we see that Paul owes $32,000 on a monthly car loan. We're going to make that $32,000 the present value. It has a 5-year term with an APR of 4.8% with monthly payments. So each one of these numbers represents a month, and the periodic rate is calculated by taking the APR and divide by the number of periods. So the periodic rate is 0.4%. The question is, if she makes payments for $700, how long would it take for her to pay off the car loan? If we calculate what the payment would be over a 5-year period monthly at 4.8%, the payment would be less than $700, but then she would take the full 5 years. So here it doesn't really matter that the maturity is 5 years. We just care about how soon can she pay off the loan if she makes $700 payments. Now in a formula, the solution would look like this. We have the present value of an annuity formula, and we're going to solve for n. Now you do not have to do that. You have your financial calculator to solve for n for you, and makes things go faster and gives you less of an opportunity to make a calculation error. Make sure you make one negative and the other positive. If it's harder to see it that way, of making the sometimes easier to think of it this way, though. Take the perspective of Paula, who is receiving $32,000, so therefore it's positive, but then makes payments of $700, and therefore I make that negative. But it's the same answer from the bank's perspective. In that case, this would be negative, and that would be positive. The important thing is that we reverse the signs, and we have the default value of future value 0 left intact. So let's put everything into our financial calculator. We get an n of 50.59, and we see here with the answers being rounded to the 10th, that's 50.6 months. All right, let's move on to the next problem. This question is a DuPont equation problem, and let me use this moment as an opportunity to review what the DuPont equation says. So the DuPont equation says that the return on equity is equal to the product of the profit margin, the total asset turnover, time, and the equity multiplier. So you need to know this DuPont equation here, this identity. We also want to keep in mind what each one of these ratios actually is defined as. Now, return on equity is defined as net income divided by the book value of equity. The profit margin is defined as the net income divided by the sales of the company. The total asset turnover is the sales divided by the assets. And the equity multiplier is defined as the assets divided by the equity. Another thing that is useful and really crucial to remember is the balance sheet identity. So if you can remember that assets equals debt plus equity, and I'm being very loose here in my definition of debt here. Really it's just liabilities, but sometimes we loosely call the liabilities debt. Just keep that in mind, because when you get leverage ratios, which means the amount of debt that's used, sometimes they can be represented in many different ways, like equity multiplier, but then we could do debt to assets, which is called the debt ratio, or we could do the debt to equity ratio. All right, now after that review, let's go into this specific problem. It tells us that Bryant Builders has a profit margin of 10% to last turnover of 0.5 and debt to assets ratio of 20%, and they want to double the ROE. Well, this is an opportunity to use the DuPont equation. However, notice that we're not given the equity multiplier, we're given debt to assets. Do not confuse debt to assets for equity multiplier. Assume that just because we're using the DuPont equation that that last number has to be the equity multiplier. It clearly is not. So let's uncover what the equity multiplier is currently. So debt to assets is given to us as 0.2. Now, if we use the balance sheet identity, that means that 1 minus, and I'll just abbreviate the debt and assets with a D and an A, 1 minus that has to be the equity to assets, because the sum of debt and equity is the assets. So the equity to assets has to be 1 minus 0.2 or 0.8. Now, we need assets over equity, however, and we just have to do one more manipulation. Just remember that the reciprocal of something is the same as, or 1 over a fraction is the same as the reciprocal. So that's 1 over 0.8, and that's 1.25. All right, so now let's calculate what the ROE is currently. We're going to plug into this formula here. We're told that the profit margin is 10%, the total asset turnover is 0.5, and now we know that the equity multiplier is 1.25. So we have 6.25 is the current ROE. Now the company wants the new ROE to be 2 times that amount. So they want it to be 12.5%. Now, we're told that the asset turnover will remain at 0.5% and the profit margin will increase to 15%. So they're able to improve the profit margin. Total asset turnover, they can't budge. And so the remaining thing to change would be the amount of debt they take on. So let's solve for the equity multiplier first. In the end, they want to know the new debt to assets ratio, but as we showed here, if I can find the equity multiplier, I can find the debt to assets ratio. So let's just rearrange this formula I have here. So the equity multiplier is 12.5 divided by 15 times 0.5, or 12.5 divided by 7.5. And the equity multiplier is 1.66666666, and now we just need to convert that to debt to assets. So let's keep in mind that's assets over equity. If I want equity over assets, just take the reciprocal of that, and that's 0.6. And then 100% minus 60% has to be the amount that's financed with debt, and that's the debt to asset ratio. So the answer to this problem would be 40%. So know how to make these manipulations of the leverage ratio, and also keep in mind these numbers, because you could also be asked a dollar value given a ratio after you discover it. So for example, if you know that there's $1 million in assets, we know that the company needs to have $400,000 in debt, right? That's very important to realize. All right, let's move on to number 4. We have a Chapter 12 problem here. It's a portfolio beta problem. All right, so we have a $1 million portfolio of 10 stocks. It holds $100,000 of one stock with a beta of 0.85. And we don't know what the betas are of the other stocks, but we know that the portfolio's beta is 0.95. So let's just start writing things down here. So we know that the 0.95 beta is obtained by 9/10 of the other stock's beta, and then 1/10 of this particular stock that has a beta of 0.85. And I did 1/10 in my head because it's 100,000 divided by 1,000,000. Let's solve for what this is, because we want to calculate the new stocks beta. Now, the new portfolio beta is targeted to be 1.05. We're not changing the other stocks here, and so that will stay the same. That's what we want to solve for, what I circled. But we are going to replace this stock with another stock, and it has to have some particular beta so that we can get the portfolio beta to increase by 0.1. So if I solve for 9/10 x by just rearranging the formula up above, I get 0.865. So this is what's going to go into there. I'm just going to abbreviate new stock with NS, and now we just have a single variable to solve for, and we know that we can do it. So the beta of the new stock, by just rearranging things, and then, oops, sorry for that. Is 1.85. And there we see the answer, answer B. All right, let's go on to the next question, number 5. This question is a question about a stock. Now this is a stock that has an earnings per share of $3, and it pays out all of it. It pays out all $3 as earnings. So a few things. This means that the dividend is $3. Now you might wonder, well, what about the dividends in future years? Recall the formula. The growth rate of dividends and also earnings per share is the retention rate times the company's return on investment, and which we proxy typically with return on equity. Now, if you're paying out everything as dividends, the retention rate is 0, and therefore the growth rate is 0. So therefore we know that this stock currently pays $3 in dividends as well as earnings, and that doesn't increase. Now the market is currently pricing this stock at $30 right now. That means that the market has in mind some required rate of return for this stock currently. And we can use the constant growth dividend discount model here, which is, let me just review that formula. So we want to use the dividend in 1 year. In this case it's $3, and we've already discussed that the growth rate has to be 0. So this reduces to 3 divided by R, which means that R is 10%. So this is the required rate of return that the market has on this stock. Now, that price is before the market has come to believe now that earnings will now start declining by 5% a year. And if they're paying everything out as dividends, that means that the dividends will be declining by 5% every year. So now we have a situation where the first year's dividend is 3 times 0.95, 1 minus 5.05, and that's going to keep, so each year's dividend will keep declining. Now each year the dividend is still positive, it's just that every year's dividend is less than the year before. So let's apply the formula. We want to get this new price, dividend in year 1 divided by 0.1 minus 0.05, because the growth rate is a negative growth rate, which means that we're going to divide the numerator by 0.15. So we got 3 times 0.95 is 2.85 divided by 0.15, and all of that equals $19 even. And if we look over here, we see there's the answer of $19. Notice that the answer is not 0. Just because the growth is negative doesn't mean it's a worthless stock. The dividends are still positive in the future. All right, let's go on to number 6. This is another Chapter 12 beta problem, and beta of a portfolio problem. All right, so we have FedEx and Costco with their betas, and we have a portfolio, 30% in FedEx, 70% in Costco. We could do this in one of two ways. One, we could find the expected returns of both and then use the weights to get the beta expectation, or get the beta of the portfolio and then plug that once in the security market line equation. So I'm going to do the latter. So let's find out what the beta is of this portfolio. So we have 30% put into FedEx, and FedEx has a beta of 1.6, and then we have 70% put in Costco, and that has a beta of 0.6. So we got 0.3 times 1.6 is 0.48, and 0.7 times 0.6 is 0.42, and we have a beta of 0.9. And now we can calculate the expected return of this portfolio by plugging into the security market line equation. And let me just review what that equation is. Right now we are told that the risk-free rate is 4%. We just calculated the beta of the portfolio is 0.9, and we are told that the market risk premium is 9%. So that means we don't subtract anything from that 9. The risk-free rate has already been subtracted from the expected return of the market. So we got 8.1 plus 4. We get 12.1% is the expected return on this portfolio, and the answer is A.